All right, so this is another application question. We're going to use our calculator for this because we haven't learned all the properties and how to algebraically determine them. So it says a frog sitting on a rock jumps into a pond. The height h in centimeters of the frog above the surface of the water as a function of time in seconds since it jumped can be modeled by that function. Okay, so graph it. So we want to basically get your calculator out, go to your y equals, and that's what? Negative 409, oh, clear off what you have, okay, negative 490, a little bit hard to see actually on this version of it, so negative 490 x squared instead of t, plus 150 t, which is x, plus 25. Now, if you have a standard screen and you graph that, you might not see anything. So you can see it, the calculator is chugging away, can see part there, okay, but not, it's pretty hard to see what's happening, right? So, you know the y-intercept's 25, so at least in your window you want to go to at least a maximum of 25, if not higher, because the frog is jumping up and then coming back down. X values, negative doesn't make sense, it's time, so I'm going to make that 0. And I could tell from that I don't need to go to 10, because 10 would mean it was in the air for 10 seconds, and a frog jumping for 10 seconds doesn't quite make sense. So I'm going to say maybe 3 seconds. And then again, 0 for the height, and I'm going to go up to 30. Maybe I'm going to change it. I'll do a scale of 5, and then let's graph that. So still can't see the maximum, and I don't need that. It's not in the air very long, right? So I'm going to go basically to 1 second, and then my maximum, I'm going to go up to, let's do 100. Now 100 is too big. Is it too big? Does it matter? Doesn't really, as long as you can see it. Here we could, we don't even need to go 1, but we could reduce this to, say, 50. That's pretty decent. Okay, so sketching that. All right, so we're going to go this, and then something like this. So this, remember, is time. This is height. Okay, so graph it. Really, when you do a sketch like this, so this isn't graphing with a scale, we're sketching it. We do want to label any intercepts and any maximum or minimum points. So that's going to kind of, we're going to go through the work here, each part of the question, and then we'll go back and label it. So the first is, what is the y-intercept? So y-intercept, so if we go trace, that's when x is 0, so just punch in 0, enter, we get 25. Do we even need to do that? If you look at the equation, where if we find h of 0, then that's going to be negative 490 times 0 squared plus 150 times 0 plus 25. So that's equal to 25. It's always the constant term if it's been simplified. So this is 25. So what does that represent in this situation? Well, that's the height of the frog at time 0. So the initial height. Initial means at time 0. Okay. And so it's sitting on a rock when it jumps, so the initial height means the height of the rock that it's sitting on. Okay. What maximum height does the frog reach? When does it reach that? So we want to find this coordinate here, this vertex. So we're going to go second trace, which is calc. We want to find the maximum point. Left boundary, so I want to go closer to the left. of where I think it is, enter. Then cursor to the right of where I think it is, enter, and enter. So that is, now what does it say? It doesn't say what to round it to. So let's go to 2 decimal places. So 0.15 and 36.48. 0.15 and 36.48. 0.15 and 36.48. Okay. So the maximum height, so max height is 36.48, and this is in centimeters, at time of 0.15 seconds. Right? When does the frog hit the surface of the water? That's this point here. So we want to find that x-intercept. A couple of ways of doing it. One way, remember, is to put y equals 0. So we want to find out what time when the height is 0, y is 0. So if we graph that, then we'll use the intersect feature. So second trace and intersect of first curve. I don't even see where it's flashing, so I'm going to go cursor till I can see it. There we go. So enter on that, enter on the second curve, and enter. So 0.43. Let me round it. Okay, what are the domain and range of this situation? So I better label 0.43 here. So the domain is between 0 and 0.43. And this is for time. Movement of the set of reals. And range is the height. And that's from 0 to that maximum height, which was 36.48. And how high is the frog? 0.25 seconds after it jumps. So that's when, make sure you're in trace mode. Okay, you can see it flashing. And then if I just enter 0.25, because that's an x value, it will go right to that point. 31.875. Okay. I didn't round it to 2 decimal places because it's actually a terminating decimal, and they didn't ask us to round to anything in specifically. So that's an application using your calculator.